Hi to all. Today we are going to see Unit 2 Network Topology in Fundamentals of Electric Circuit subject, FEC subject for first year ECE according to R20 regulations. The first unit, Electric and Magnetic Circuits, we studied previously. Now Unit 4 also completed, that is Network Theorems. Because why we covered Unit 4 is because Fundamentals of Electric Circuits lab is parallelly going on with the subject. Therefore, it is very easy to understand the students if they practiced practically and theoretically, they can easily understand. Therefore, we went for Unit 4. Now we go for Unit 2 Network Topology. Let us see the syllabus. This is the syllabus, Fundamentals of Electric Circuits, FEC simply. Let us see the syllabus. Unit 1 Introduction to Electrical and Magnetic Circuits we completed. And the links in playlist you can check that links. Unit 2 Network Topology. Previously we covered Unit 4, that is Unit 4 Network Theorems. What is network? What are the network theorems? Reciprocity, Thevenin's, Norton's, maximum power, Millman's, and compensation theorems for DC excitation. Because parallelly we conducted lab to understand to the students carefully, we go for network theorems. Now we go for Unit 2, that is Unit 2 is Network Topology. Let us see the syllabus of Network Topology. Network Topology. This is the syllabus regarding Network Topology. Unit 2 Network Topology. What is Network Topology? It is a graphical representation of a graph. A network can be represented as a graph. For complex circuits, we are using network topology. The definitions regarding network topology like tree, co-tree, node, branches, links, all this comes under definitions. Graph, what is tree, what is basic cut set and basic tie set matrices for planar networks. What is the planar network, what is non-planar network, and loops, network independent and dependent voltage sources, duality and dual network, nodal analysis, mesh analysis, all comes under Unit 2. Coming to network topology, it is the important step in procedure for solving any circuit problems. Any circuit which is drawn between, if the circuit is very complex, it is very simple to solve the problems by using network topology. If the branch currents are as variables or loop currents, it is also known as mesh currents. Alternately, number of independent node voltages, if the circuit is very complex, suppose the circuit is like this, if the circuit is very complex, or if any voltage source is also there, it is very difficult to calculate current through various branches. For a simple network solving, with few elements we studied previously in Unit 4 network theorems we can easily apply if the number of branches or loops are very less. There is no difficulty in selecting branch currents or node voltages. Suppose the circuit difficult ga unnappudu, for a difficult circuit how to solve, we go for network topology. Network topology is the only option. For simple networks involve few elements, there is no difficulty because selecting branch currents or node voltages. The set of linearly independent equations can be easily possible, but number of equations will be more if you consider it is a loop 1, loop 2, loop 3 like that. 3 loops are possible, number of equations will be more. Suppose here also voltage source, it is also voltage source, it is also voltage source, like that. Suppose if you go for microcircuits or integrated circuits, very large scale integration, ICs, integrated circuits, number of components are connected, more number of components, complexity is more. Therefore, we go for network topology. A systematic and step-by-step method is required to deal with such a complex networks is called network topology. It is simply, we can say, it is also called as graph theory. It is also called as graph theory. Network topology, another name is graph theory. We call it is. Why? Because any network can be represented as graph. The description of network in terms of their geometry is referred as network topology. Network topology is represented, suppose if it is a network A network consists of like this. Network topology means it is a graphical representation of electrical circuits. Graphical representation of electrical circuits is called network topology. It is useful for analyzing the complex circuits. Suppose the circuit is complex like that, you can assume this is the one circuit consists of resistors and inductors and resistors, one voltage sources plus minus, like this a circuit. If you consider here also one resistor and one voltage source. Such a complex circuit can be represented by a graph, that is graph theory. It is useful for analyzing complex circuits by converting them into network graphs. Network topology is a graph theory. We are converting the voltage source is short circuited while drawing the graph. You can assume here the branch between 1 and 2 nodes, a branch 1 is connected. Branch 1 is connected between 1 and 2 nodes, and inductor L is connected between 2 and 3 nodes. Between 3 and 4, this is the common node, you can observe. This is the common node 4. Between 3 and 4, a voltage source V is connected. Between 1 and 2, a resistor R1 is connected. Between 2 and 3 nodes, a branch that is L inductor branch is there. This is R2, R3, assume that. Then this is R4. The number of nodes are more because here 1, 2, 3, 4 and this is 5, fifth node, and voltage source is connected between, this voltage source is connected between 5 and 3 nodes, and R4 is connected between 1 and 5 nodes. Number of nodes are 5. We can represent the graph for this circuit or network is like this. Between 1 and 2, it is a node 1 and node 2, node 3 and node 4 and node 5. We can consider these are the nodes. Between 1 and 2, a resistor is there. Directly we can write a resistor is represented as a line, a single segment line. Between 2 and 3, it is 1, node 2, node 3, node 4 and 5. The graphical representation of electric circuit is called network topology. That is 1 and 2 we connected a line. Between 2 and 3 inductor also we have to connect a line like this. Between 1 and 4 R2 is there, that also represented with a line. This is node 4. Between 3 and 4 a voltage source is there. Voltage source will be short circuited while drawing a graph, whereas current source is open circuit while drawing a graph. That we have to remember. Voltage source ni short chesi manam line draw chesam, alage resistance ni kuda manam direct ga draw chestam. And between 1 and 5 you can see here R4 is connected between 1 and 5. That means a line we have to draw. Between 5 and 3 a voltage source is there, that should be short circuited. This is the graph, connected graph of a network. Here we are going to see various definitions of this branch, node, degree of nodes, loops, various definitions regarding. Simply we are converting a network into a graph. If you provide an arrow mark directions in some other directions, whatever you can consider these directions, okay, these are oriented graph. If the graph is represented with current directions, it is called oriented graph or directed graph. It is a connected and oriented graph. What are the various definitions we can see by the notes? You can download the notes by the link provided in description. For this network, we are going to see a graph, network graph it is. Number of nodes in this network is 4. It is node 1, 2, 3, 4. 4 nodes are there. For that, a connected graph is like this. If you provide arrow mark, it is a oriented graph or directed graph. If you are not mentioned these arrow marks of current direction in various branches, then it is called non-oriented graph. Okay, different definitions we can see. Simply we are representing, if voltage source is there, then that will be short circuited. In this circuit there is no voltage source, that's why we are not represented. A single resistance is represented as a line between 1 and 4 node. You can consider these nodes also your wish, according to your wish also. What is a branch? What is a branch? Different definitions we are going to see now. Branch. A branch ante between, what is a branch? Between two nodes a branch will be there. Between two nodes a resistor is there. Then we can represent this as a single line segment. It is a branch of a graph. It is the branch R1 is connected. A line segment replacing one or more network elements that connected in series or parallel is known as branch. Between two nodes ఒక branch ఉంటుంది, అది గుర్తుపెట్టుకోవాలి. Number of nodes required for one resistor is 2 nodes, 1 and 2. Branch contains only current and voltages. 2 branch currents and voltage across this branch is VR. Branch is one single line segment we are replacing. Or what is a graph? A network graph is a network in which all nodes or loops are retained but its branches are replaced by lines. If you replace with lines, then it is called a graph or linear graph. A graph or linear graph. If you replace all the network elements with the single lines, but while replacing, it is important what I told, voltage source will be short circuited. Voltage source will be short circuited. Current source will be open circuited. If any circuit having current sources in one branch, that branch will be removed or open circuit. That we have to remember. Network graph is in which all nodes or loops are retained but branches are represented by lines. That is network graph. What is meant by node? Node means when it is also called junction. Interconnection of two or more elements is called, two or more branches is called node. Interconnection. Suppose it is a node because we connected this resistance and this resistance and another resistance. This is the node 1 we assumed previously. Terminals of branch are called nodes. This is the one branch 1 and node 1, 2. Terminals of branches are called nodes simply. Degree of nodes. What is meant by degree of nodes? Number of branches connected to single node. Node 1, number of branches are 1, 2, 3. 3 branches are connected. It is called degree of node. What is meant by loop? What is meant by loop? Loop is a closed contour selected in a graph. A loop is a closed contour selected in a graph. We can see this loop. What is this loop? Loop is, this is one loop. This is one loop. We can see here. This is one loop. This is one loop. This is one loop. A loop is a single contour selected in a graph. What is meant by mesh? Mesh already we saw in different definitions. What is mesh? A loop which cannot be further divided, that is called mesh. A loop which does not contain any other loop in it, then it is called a loop. A loop which does not contain any other in it, then it is called loop. Inside of this loop there is no another loop, then it is called as mesh. Mesh అంటే ఒక లూప్ మళ్ళీ డివైడ్ కాకపోతే, ఖచ్చితంగా మళ్ళీ డివైడ్ చేయలేదే మెష్. దట్ ఈస్ కాల్డ్ మెష్. Now we go for subgraph and its types. A part of the graph is called a subgraph. Suppose the graph is like this. It is the graph which we drawn previously. This is one graph, not oriented graph. If you provide direction, it is subgraph. It is a oriented graph. A graph is like this. Some part of the graph is called subgraph. If you consider it is one part, node 1, 2, 3, 4 like this, it is the part of the graph. It is a subgraph. We get subgraph by removing some nodes. If you remove node 3, then it is a subgraph. Some branches also you removed of a connected graph, then you get subgraph. So number of branches or nodes in a subgraph will be always less than original graph. Number of nodes here is 4, but in subgraph it should be 2 or 3, like that. It is also subgraph. 1, 2, 3 nodes. 1, 2, 3. The subgraph again divided into 2. They are tree and co-tree. Tree and co-tree. What is a tree? A tree is a connected subgraph which contains all the nodes of a graph, but there should not be any loop in that subgraph. What is a tree? A tree is a graph that contains all the nodes, but there should not be any loop. That is called tree. It is a subgraph. Tree is a subgraph. A tree is a graph containing all nodes of a graph, but no closed path. There is no closed loop. The branches of a tree is called as twigs. The branches of a tree are called as twigs. Twigs of a tree. If you consider number of nodes required to construct a tree is number of nodes, minimum nodes are total number of nodes are there in connected graph, those must be there. ఒక కనెక్టెడ్ గ్రాఫ్లో ఎన్ని నోడ్స్ ఉంటాయి, అన్ని నోడ్స్ ఖచ్చితంగా కనెక్ట్ అయి ఉండాలి. 1 is connected to 4, 2 is connected to 4, 3 is connected to 4. It is a subgraph of original graph what we drawn previously. This is the original graph we have. It is a subgraph, but it is a tree because no closed path is there. If you consider this is also a tree because no closed path. The 2 to 4 is connected nodes are, and 1, 4 to 1 and 1 to 2. This is a tree. There is no closed path. Subgraph is divided into tree and co-tree. What is co-tree? The remaining, these are the remaining links. These are called as links. Number of links are 3 here. You can see number of links. What is meant by link? What is meant by tree? A tree is a graph. It is a subgraph of original graph containing all nodes of a graph but no closed path. That is, it is a set of branches of a graph which contains no loop but connects every node to other node. That is called a tree. Number of trees can be drawn for any graph. Any graph you can draw any number of trees. What is meant by this one? This one, or this is called branch of a tree or twigs. It is a branch 1, 2, 3 branches are there. These 3 are the branches of a tree. Tree branch means for a given tree what are the branches are connected, that is called tree branches. Here 1, 2, 3 are tree branches, or simply we can say it is a twigs. The remaining branches of a tree is called a link. This is a link. You can see here 3 to 4 is not connected, but dotted line represents a link. The remaining branches of a tree which are not connected, if you draw a dotted line, it is called link. Number of links, what is the relation between number of links, number of branches and nodes? You can see now. These are some definitions, and what is the relation also important. Now, what is the important relation between nodes, links and branches? The relation between nodes versus links and branches. Let n be the number of nodes in a graph. In previous graph we assumed 4 nodes. So number of twigs will be n minus 1. It is very important. You have to understand this. Number of twigs are links. Number of twigs are the branches of a tree is called twigs. Number of twigs or number of branches in a tree will be node minus 1 only. Number of branches you can connect. If you connect all branches, then it is a closed path it will become. Suppose oka circuit oka graph ila undi, connected graph 1, 2, 3, 4 nodes are there. If you connect all the nodes, then it is a closed loop. 1, 2, 3, 4. Therefore, number of nodes in a graph n equal to 4. 4 minus 1 twigs will be possible to construct a tree. That is the important, n minus 1. Number of twigs or number of branches in a tree is n minus 1. That is we have to remember. Suppose n equal to 5 nodes are there. n minus 1, 4 twigs are possible for tree. Next, L is the number of links, total number of links in a graph. Number of independent loops it is also called. Links are nothing but number of independent loops also. Therefore, L equal to number of links is given by L equal to B minus N minus 1. This is the important formula. B minus N minus 1, or simply we can say B minus N plus 1, where B is the total number of branches in a graph. Suppose number of links L for 6 branches. 6 branches are there. Previously we assumed one diagram. In this 6 branches are there. 6 branches, 1, 2, 3, 4, 5, 6. 6 branches. This is 6th branch. 6 minus number of nodes are 4 minus 1. That is 6 minus 4 minus 1, 3. 3 links are possible. 3 loops are possible if the graph is like this. That is the relation between links, nodes and branches. Here important, మనం గుర్తుపెట్టుకోవాల్సినవి, number of pegs or branches of a tree is n minus 1, nodes minus 1. And number of links or number of loops depends on links only. L equal to minus 1. L equal to B minus N minus 1. ఈ ఫార్ములా మనం ఖచ్చితంగా గుర్తుపెట్టుకోవాలి. These are the some important definitions. Next we will continue.